I have been focused on ACE2 autoimmunity. And my concern, part of the concern, is whether or not we see a reactivation of that when somebody gets infected again after their immune system has been primed from whatever source. So in that sense, I then go back to the science. And what I'm looking at here, this is just a paper from 2021 talking about ACE2 and the angiotensin 1 to 7 and this renin angiotensin system. And it's just looking at the way how it works. But the thing that I was very, very interested in, and so I'd searched this in terms of this paper. If I can't find it here, yeah, there we go. So immunohistochemical analysis showed abundant ACE2 positive cells in diseased vessels, particularly in the neointima and media and in newly formed angiogenic vessels and vasovasorum. Okay, this is the bit here that really, really is important. And it's telling us that ACE2 is in the vasovasorum of these big blood vessels. Okay, now, in order to understand the significance of that, so I'm tying two things together here now. The fact that the vasovasorum, I'm trying to think if I have an image that will show you that. I had it before. I'll have to see if I can find it while I'm talking to you. But the vasovasorum represents the blood vessels that are supplying the blood vessels. They are like the blood vessels inside the blood vessels, and their role is to keep nutrition to the lining of the blood vessels. Okay, and I think that this is such an important point that I'm going to show you this one here. I just have to find the image because you need to see it in order to understand what it is that I mean when I talk about the vasovasorum, because this is potentially the mechanism that leads to what the embalmers are seeing with the large clots. This is why I said that I'm tying a number of things together. And this CD8 targeting is very, very critical in the picture. So here is the example of a large artery with the vasovasorum. Once the image comes up here, you'll be able to see what I'm talking about. And this vasovasorum, based on what I was saying, can then get targeted. So this is a large muscular artery. It's not quite the aorta, but one there. So this is the smooth lining of the blood vessel. Now, this has to be smooth because if this is anyway even a little bit rough, it will automatically start to clot. And you can see the muscle layer here around this artery. But on the outside here, this represents where the vasovasorum are. So these blood vessels here, this is the artery, this is the vein, they carry the blood supply. This is it here. Red is artery, blue is vein. So this is supplying the outside and giving nutrition all the way to the inside of this very big artery. So even though it has blood flowing through it, it's not being supplied with oxygen from this blood. It's primarily from the vasovasorum around it. So anything that damages the vasovasorum is going to then damage the lining inside the large blood vessel and therefore lead to clots. So what I'm saying is that ACE2 is predominant, is highly concentrated in these vasovasorum. So suddenly, if you have the immune system then targeting these cells, you'll get inflammation. It will then reduce the oxygen supply, and then you'll have damage to the lining of this artery, and then this will lead to clots. And this is the essence of how the combination of two things seem to make sense. One is the autoimmune targeting that would occur, and just so that you understand what I'm talking about with regards to this targeting that occurs, remember, it's not just antibodies that will target the vasovasorum, but these T cells. And what they'll do is that they will kill any cell that has ACE2 on it. And that will then mean it will cause blockages in the blood vessels there, which will reduce oxygen supply, which will then cause inflammation and damage to the big artery, which will then lead to clots. So it's this sequence that I think is a
A warm welcome to this talk, Tuesday the 8th of October. Now, Mr Russell Broadbent is the Member of Parliament in Australia for Monash, the constituency where the new Pfizer factory is under development. And he's written to the Prime Minister of Australia asking for the suspension of Moderna products. Could Australia be the first country to suspend all mRNA products? It's really hard to see how the Prime Minister of Australia can ignore what I'm about to show you on this video. Now, we're going to be looking at this letter here to the Prime Minister, and it's going to be based on this evidence here, largely from Canada but other places. There's another letter that we're also going to look at. These are of immense significance. Now, just to let you decide if you want to watch this video, it's Mr Russell Broadbent, the Member of Parliament for Monash, is written to Anthony Albanese, the Prime Minister of Australia. Now, what he says is this. This is from Mr Broadbent's website. In short, there is compelling evidence that synthetic foreign DNA, deoxyribonucleic acid, encapsulated in lipid nanoparticles can integrate into human cells. So what he's saying is reasonably straightforward. We have human cells here. These are the cells that billions of cells that comprise our body. And the lipid nanoparticles can absorb onto the membrane of our cells. The membranes of our cells are lipid. The lipid nanoparticles are obviously lipid. Now, we know that this allows the RNA to get in, which is the way that these genetic products are supposed to generate immunity. But now we also know that the DNA contamination, which is not supposed to be there, can also get in. So we end up with the DNA, deoxyribonucleic acid, the DNA in the cells where it's not supposed to be, this DNA contamination. So this is the concern, and the implications of this are potentially quite frightening, really. So in short, there is compelling evidence that excessive synthetic foreign DNA, so again, synthetic, this is foreign DNA getting into our cells, encapsulated in lipid nanoparticles, can integrate into human cells. And to me, that science makes perfect sense. And I know it does to other leading scientists around the world that I've talked to. Not that I'm putting myself in that category, not by any means, but I've talked to many leading scientists around the world who agree that this is what happens. Potentially leading to genetic instability, cancers, immune system disruption, and adverse hereditary effects. Now, this is from Mr. Broadbent. Whether we're allowed to publish this or not, I don't know. We'll just have to wait and see. I again urge the Prime Minister to immediately suspend the rollout pending an urgent investigation, one which allows for free and open scientific discourse. So we need free and open scientific discourse to, one, help uncover the true facts. Now, is there anyone out there, I don't know, who might be listening, insert name under this, who could possibly, at least publicly, disagree with this, that we need free and open scientific discourse? Now, some people might think they don't want free and open scientific discourse because it might reveal things that they don't want. But publicly, I don't think anyone in the world could say, well, you know what? I don't want free, open scientific discourse. Of course, this is what we need. Now, let's get to these letters now. That's the main thing that this video is about. And of course, as always, all the links are there. Click on that. Make sure I'm not making this up. This information is all now public domain, which is why we're free to discuss it, of course. So here we have one letter from, this is to the Prime Minister of Australia, We, the undersigned, are writing to seek an immediate and urgent investigation following the discovery of DNA contamination in messenger RNA COVID vaccines in Australia. Now, these are generic Moderna and Pfizer products. The idea that there's a big problem in Australia and no problem at all in the United States or the United Kingdom is unlikely. Let's carry on. On the 18th of September 2024, an alarming report was released by Canadian virologist Dr. David Spicer confirming significant synthetic DNA contamination in Pfizer and Moderna COVID-19 vaccines used in Australia. A copy of the report is attached, and we're also linking that report there that you can look at for your own perusal. Let's carry on with this first letter before we look at the second one. The findings indicate DNA contamination levels up to 145 times. 145 times higher than Australia's Therapeutic Goods Administration TGA safely limits. These findings have also been replicated in Germany, Canada and the United States. This information adds to the growing safety concern surrounding these vaccines. Now, I'm going to leave that there. You can download it for yourself and read it. Perfectly readable. Australians deserve answers. We strongly recommend that the use of all COVID-19 vaccines in Australia be immediately suspended, while an urgent independent investigation is established to understand the broader implications for Australians of the erstwhile widespread use of these products. And again, this is not just an Australia problem by any means. Let's have a brief look at another letter that is sent here. This one. So this was the latest one on the 25th of September. I refer to my letter of the 20th of September calling for the government to immediately suspend the use of Pfizer and Moderna COVID-19 products due to evidence of significant synthetic DNA contamination. Again, this really can't be. I don't think the Prime Minister can ignore this. This is such high profile now. Unlike the thalidomide tragedy, which of course resulted in these appallingly deformed babies, this severe teratogenic effect that happened. Unlike the thalidomide tragedy, which resulted in over 10,000 victims globally, the COVID-19 vaccines have been administered to more than 20 million Australians. I don't know how many around the world. Billions. Totaling over 63 million doses. The contamination detected in these vaccines, if not addressed, presents a substantial risk with the potential for these dangers, such as genomic integration, the DNA getting into human genomes, is a concern, and potential long-term health impacts to multiply with each additional dose administered. Immediate action through a suspension of these products is critical to mitigate future risk. And again, read the whole letter there. It's all available. And let's just see, is this the one? Yeah, so here we have some of the signatories. And what we notice is we've got world-leading medical professors. Now, I met several of these people personally and interviewed them. Professor Robert Clancy, Professor Wendy Hoy, Professor Angus Dalgleish. These are world scientists of the highest caliber. Professor Dalgleish, Professor Hoy and Professor Clancy are all lifelong physicians. I've had the privilege of talking with all of them. I've haven't met Angus Dalgleish personally, but we've done several interviews. These are the world's leading medical professors, and they really can't be ignored. Not if you want free and open debate. And many others, some we've had the privilege of talking to on this channel, but leading medics and academics and professors around the world, and legal expertise as well. It's just a few of the people there that have signed this letter. I mean, when people of this calibre are writing to the Prime Minister simply can't ignore it. And if these products are suspended or banned in Australia, then other countries around the world have got serious questions to answer. They've got serious questions to answer now. They're just choosing not to answer them. So I really feel the Australian Prime Minister has to answer this in a significant way, and we look forward to that. And well, I'm going to leave that there for now. That's the main essence of what I wanted to talk about. We'll come back and look at the evidence in more detail, but for now, download the letters for yourself. They're in the public domain. Tweet them, retweet them, do whatever you want, and let's get people around the world debating this, because we want. Let me read this from Mr. Broadbent's site. I'll just maybe show you some of his. This is an excellent video. We might use some of that later. That's the letter, and this is Mr. Russell Broadbent here. And as we see, his constituency is Monash, where this Moderna factory is scheduled to start chucking out. As far as I remember, it's about 100 million doses of mRNA products per year. So we want free and open scientific discourse. So we want free and open scientific discourse. The brains around the world exist. Emancipate them, liberate them to do their job, and get rid of all this secrecy and political and economic intrigue. Thank you for watching.
You know, this conversation about autopsies is effectively like when a lion is targeting a buffalo and it grabs the neck and it just holds it, knowing that it's a matter of time before that animal is down. This is like what autopsy is. It is the crunch. It's the thing that everybody is afraid of looking at because the implications are so significant. You can't get out of autopsy evidence. And this is why it seems that it's a struggle to find peer-reviewed published data. And as a result, sometimes you have to use non-peer-reviewed data. And I'll be talking about Professor Arnie Burkhart's documentation again. And it's that kind of picture that we have to therefore concentrate on. So what I'll start with is one of the questions that I'd had very early on in the pandemic. And it was around the vaccine that was developed against SARS-CoV, or not developed against SARS-CoV. And I did this in about October of 2022. At the time there, I had asked the question simply, even though we knew about SARS-CoV in 2003, why was there no vaccine that was developed against it? And it was very simple, is that by the time they had done all the studies, including the challenge studies, they came to this conclusion that even though the SARS-CoV vaccines all induced antibody protection against infection, challenge, that means on re-exposure of the mice at the time and ferrets, of any of the vaccines led to the occurrence of T helper type 2 immune pathology, suggesting a hypersensitivity response. This is pretty serious, and it's therefore something that nobody wants to find now, but it is essential for us to be able to get to the bottom of. Because without that understanding, we are flying blind. This is why I talk about the fact that autopsies are the way that we'll be guided to find answers for people who may be having issues, and we'll learn how to be able to mitigate it. So I know that by hammering home this question about autopsies, there is no easy way to get out, because everyone in the medical and the scientific community knows that autopsy is the gold standard. There is no easy way to go. So one of the things that we have to be able to understand is this thing about vasculitis. That's really what I am looking for here. And I've got this here from my pathology report because I thought this was a pretty good description as to what was going on. You have here a blood vessel, and you have the lining of the blood vessel going around. This is the inside of the blood vessel with the endothelium, and the outside of the blood vessel with the tunica adventitia. And then what happens in vasculitis, that's inflammation of the blood vessels, you have these accumulations of perivascular infiltrates all around the blood vessel. And then it can damage the walls in the context of this inflammation. It can occur just commonly from a viral infection, but if it's present, this is always a very, very serious finding and something that we try and look for and try and mitigate. There is no easy way out of a vasculitis if we start to find evidence of it in the context of what is happening. And so when I took this paper that we looked at before with regards to the immune pathology, immunization, as we said, with the vaccines for SARS-CoV in 2012. So this paper here was published in 2012. So they were looking at trying to find solutions for the SARS-CoV in case there was a SARS-CoV-2. But they realized that it led to pulmonary immunopathology unchallenged with the virus. And so what I then did is that I did a search of this here, and you can find it here, is that I then looked through doing the search for perivascular infiltrate. So everywhere there was perivascular in this paper. And you can see here that they were looking for perivascular cellular infiltration. As I said, that's indicative of vasculitis. There were 9 places in this paper that they were talking about perivascular infiltrates. Okay. So this is how I know what we saw then and what we should be looking for now. And that's what nobody wants to do in terms of seeing this, because as I said, there is no easy way to explain it away. It has to be investigated. It needs to be clarified. And so there we come to the question about what did Professor Burkhardt find? So in case you didn't know, he's a German pathologist. He had looked at COVID early in the pandemic, trying to understand it. He was one of the early people who published papers on it, trying to understand the disease. And at the same time, he also looked at what happened in people who had been vaccinated who had died. Sadly, he died sometime after he'd made this publication, which was not appreciated. And so, in a sense, we lost this valuable work that he was doing. So here is the work that he did. And he was talking about at the time that their causative role in terms of the things that were going on with regards to after all of the investigations, the autopsy investigations. And so in this, he again highlighted, and he was looking here at 15 cases of people who died, and they recorded their age, the time of death. So this one here is a female, 82 years old. She had 2 doses, and 37 days after she had died, they did an autopsy. So they didn't die of COVID. They died of other causes. And you can see all the different time frames: 31 days, 68 days, 65 days, 11 days, 8 days, 37 days, different vaccine candidates. This one was unknown: AstraZeneca, Pfizer, Johnson & Johnson, Moderna. So this is across the board. This is the kind of research that should have been done, that really wasn't done. But as I explained to you, is that when they looked at all of these cases, this is the thing that stands out. There was extensive perivascular accumulation of T lymphocytes. This is the same thing that I said to you is indicative of a vasculitis, very similar to what we had seen previously in terms of the other animal studies that were done in 2012. And so this is why I'm saying that almost certainly that's why I am calling for autopsy studies, because that's what I am expecting to find as well. But without the autopsies, everything is conjecture. We keep on saying, well, we're concerned. People are dying. We don't fully understand what's going on. It must be COVID. But how is it COVID? And this is where the COVID storm comes in, because the reality is that you may find that somebody had an infection 6 months ago, then they have passed away. You do the autopsy, you find perivascular infiltration. What would then happen is they would try to label that as a COVID death. But we understand from the prior studies that technically this is a challenge situation. That means that there was immune priming and then re exposure. In that circumstance, you would therefore have to conclude that the immune priming is likely to be a significant contributor to the perivascular infiltration. That's the vasculitis. So, this is really what it is that I have been concerned about. And in terms of what kinds of diseases that it tends to cause, I'll show you here that vasculitis, as I said, is very serious. It's not something to be underestimated. And when we look at the types of diseases that are associated with vasculitis, you have large vessel vasculitis like giant cell arteritis, have medium vessel vasculitis, small, as you can see here. This is the aorta, which would be a large vessel. So that tends to be the giant cell arteritis. The Kawasaki's disease, medium to small sized arteries. The arterioles will be more the anchor-associated vasculitis. Capillaries is a glomerular basement membrane disease. And you can see the whole range of different vascular diseases that can occur. This is pretty serious stuff. And as I said, it's the one thing that is not easily evaded in terms of the community that wants to put this aside. If you start getting autopsy evidence, no argument that this has to be investigated. Here is some more evidence as to what it would look like in terms of perivascular infiltrates. This here is the blood vessel. And usually this is part of an inflammatory process. And then you have these dots, which would represent the lymphocytes and macrophages that would be accumulating around the blood vessel. And you have to remember, this is oftentimes silent. And it can take sometimes months or years before disease can present. And this is the point about trying to find ways to mitigate this if it's occurring. The first step is the autopsies. Without the autopsies, everything is conjecture. But once you have autopsies and you start to see this on a regular basis, the next question is, well, who is affected? How can we mitigate it? Without the autopsies, we can't get to the second part of the question. And this is why I'm hammering it home. You'll find that this was the point that got me censored once I started talking about this, because as I said, it is so important. It is effectively taking a big company that's making a lot of money and they say we're doing very well. And you say, have you had an independent audit? And they go, no. And you say, well, we don't know if those numbers that you're giving to us are actually accurate. We want an independent auditor to look at your numbers, look at your products, look at what's happening in the background. After they have done that, if there are no issues, that's when you say that you're okay. So not having autopsies is effectively the same as a company not being audited. And I can guarantee you investors wouldn't do that, wouldn't put their money in a company that wasn't audited, because you can't know exactly what's happening behind the scenes. Just remember, autopsy is the hole that the lion has on the neck of the buffalo. Once you keep asking for it, there is no getting out. It has to be done. Once it's done, you then have to make sure that the findings are independently analyzed and clinically made in context. And then we can start making progress in terms of finding solutions. There is no doubt that something is wrong. Even the life insurers are talking about the excess deaths now. So something is happening, and we can't know for certain what it is without autopsy. Let me just repeat this to the senses. I am not saying that the elephant in the room is the cause. I am just saying you can't exclude the elephant in the room without autopsy and without research. This is getting harder and harder to talk about because, as I said, the implications are so serious. But I don't think we have any option but to keep on pressing this point home because at the end of the day, this can affect everyone, families, loved ones, especially older people who may have other comorbidities. We have a responsibility to keep on investigating, even if it's inconvenient, and even if those in power don't want you to ask questions. Have a great evening. As we continue to navigate the pandemic, one of the issues is that whilst there's blame being thrown this way and that, at the end of the day, we still need to understand the science. We need to understand what worked, what didn't work, why what didn't work, and try and find an understanding as to where we are now. So fundamentally, me asking questions that are inconvenient are primarily there because I think we need to do more research to try and understand what is happening in terms of excess deaths. Now, some people may say excess deaths are not occurring. I think that the data is pretty clear. And when I look at our world in data here, this is the starting point. This is our world in data, as you can see here. It's looking at the period up till 2024, excess mortality, deaths from all causes, compared to the average over previous years. Now, you'll know that in some countries, they have taken out this average over previous years so that it's difficult to adjust. Thankfully, with our world in data, they're still stuck to the basic science. And all they did is that they looked at the deaths between 2020 and 2024 and the average deaths in the same period between 2015 and 2019. And this to me is the fundamentals about excess deaths because you want to see if more people are dying than you would expect before the pandemic. And when you look at this, this is just the USA. You can pick many countries if you look at this and compare them. But just taking the USA here, and this is in January 2020 at about zero, then you can see the pandemic hits. That's the first wave. That's up to May. It comes down quickly, has a little jump here. And then in December of 2021, December 2020, you have another wave here. That's probably the alpha wave going down again into May. And then you see here a rise into August and then across into to February, January 2022. This one here probably represents the Delta wave. This was the beginning of Omicron. Then it falls off. So the COVID deaths primarily occurred in this region. Okay. But what you should expect if you had up to 40% extra excess deaths, as you can see here, up to going all the way up to 32% here, this is 45% at the peak. We were here at this was 52%. So if you had that many people dying in the pandemic, you should expect that when you hit this period here with the Omicron wave that you then go below the baseline. Because we know that Omicron wasn't as severe for the unvaccinated, so the deaths wouldn't have been as severe as compared to early in the pandemic. It's not that it didn't occur. And we have now where if you're unvaccinated, you would be exposed to Omicron, so therefore people would have natural immunity. But we see this ongoing 10, 13, 15% excess mortality all the way through going up to September 2024, 7% in September. But if you notice this period here, this is the summer of in the United States, which is 9, 10, 11. This is extremely unusual. So even though it may be inconvenient, this is pretty serious. And the anticipation from Swiss Life Insurance is that they think this will go on for up to 10 years beyond. Now, we had the Andrew Bridgen in the UK lose his parliamentary seat from asking about this being investigated. And one of the reasons why I'm raising this is that my hope is that with a new administration, say for instance in the US, this is why I use the US, is that we will have people who are willing to ask the hard questions and willing to investigate it, because that's the purpose of health and public health, is to identify patterns that can put people at risk of serious harm and to try and address them. So the question is, what really is going on? Why is this happening? So in the past few days, I've been interacting with someone. I'd like to give credit, Will Thompson, who has been challenging some of my thinking about autoimmunity. He's been focused on CD8 lymphocytes, and he thinks that's the primary problem. I've been talking more about autoantibodies in COVID as being primarily part of the issue. Now, I'm going to be explaining something here that I think is very, very important. And it's part of the reason why I'm looking at this is because I am trying to predict the future. So I am not just looking at what has happened and trying to make sense of what happened in the past. I'm trying to use the understanding of the science to extrapolate into the future so that we can then think, okay, if this is going to happen, how can we mitigate it? How can we intervene? That's the job that we have to do. And so this discussion, and I have to be careful about it because this is a kind of discussion. This is why I wanted autopsies, because I needed the information about what was going haywire in terms of the immune system. So I'm going to take you through a few steps. I'll not be too long, but this is my initial thoughts as I try and break down what it is that I think is happening. The first thing that I'm going to do is I'm going to start with the fact that the prediction that we had made in early 2020, viral mediated autoimmune disease, focused around autoantibodies to ACE2. That was our hypothesis in 2020, which we wanted to study. Didn't get the funding for it at the time. But by 2024, we now have that evidence. So this was in March 2024. And again, autoantibodies to ACE2 and immune molecules are associated with the COVID-19 disease severity. And what they found was essentially that when you looked at autoantibodies, even IgG, IgA, IgM, looking at healthy versus mild versus severe, you'll notice there's not a lot of difference between the healthy and the mild. But with severe disease, in every case, you had elevated levels of autoantibodies targeting ACE2. And just in case you don't quite understand autoantibodies, what it means is that even though the virus uses ACE2 to enter into the cell, ACE2 is a normal protein and it's part of the renin-angiotensin system. And so an autoantibody is an antibody that targets ACE2 thinking that it is foreign. And what then happens is that the immune system then attacks any cell that has ACE2 on it. This is why autoimmunity is so important and one of the critical things that I've been talking about since 2020. So this focus on ACE2 was where I was. Now, this is where the piece of the puzzle came in when Will, there's something clicked in something that he said, which but it's not at the forefront of your mind. So just to make everybody aware, I do listen to people when they tell me stuff. I reflect on it, and it doesn't always make sense initially, but I always think about it and try and see if I can tie things together. And what he was talking about is CD8 cells. Now, I don't have any images to describe it, but I'm going to try and explain it. When an antigen presenting cell gets a new protein, it cuts it up into little pieces, and then it tries to find an immune cell that will target one of the pieces of, say, a protein. So if you imagine ACE2 has about 12 epitopes on it, that means 12 points that the immune system could target. And so it would then take 12 pieces of protein and it would then target it with 12 different types of antibodies. This is what it would do as well, say, with the spike protein. It wouldn't just be one antibody targeting the spike protein, it would be multiple antibodies targeting different epitopes. Okay. Now, what happens with the immune system is that the antigen presenting cell presents it to stimulate not just the B cells that produce antibodies. So the B cells, plasma cells produce antibodies, but they also train cytotoxic T lymphocytes. And their job is to target virally infected cells. And for this, I've got an image that I think is well worth you understanding. And just to get the point across, when we think about the targeting, so this is what happens with an infected cell. So in here, I'm showing you a virus invading a cell. Doesn't depending on the virus, it will depend on whether or not it goes into the nucleus. RNA viruses would probably replicate outside the nucleus, but this would represent a CD8 T cell. Now, by this point, this T cell is now trained to recognize specific epitopes on the virus. Just one. So if you imagine that just on the spike protein, let's say there were 10 epitopes, there will be 10 different types of CD8 cells targeting a different protein on each epitope. And then these cells multiply, and instead of antibodies will bind to the virus and help the immune system to pick it up and prevent it from binding and infecting. But the CD8 cells will then go, instead of targeting the virus, they kill the cell. These guys don't joke. They just see this cell is infected, kill it, destroy it straight away. So that's the difference with the CD8 T cells. And when I thought about an image to try and describe it, I'll use this image here and see if it makes sense to you. But this is the image that came into my head that differentiates the different kinds of immunity. And in this one here, antibodies are like the bullets. So these are the bullets that you fire to try and hit the virus. So if you have more bullets, you can then target the virus. This is the CD8 T cell. These are the Marines. These guys are the killers. These guys will go and take out the whole building. They're not just shooting at the virus, they just take everything down. And so when we think of autoimmunity, this represented the ACE2 autoantibodies that were being shot at cells that had ACE2 on it. But if you train T cells that they must target cells with ACE2 on it, that is a completely different ball game. That's what I mean, is that these guys are the beasts. And this is what potentially represents the storm that I've been talking about, in that reinfection not only reactivates antibodies to ACE2 and other proteins that bind to the spike protein, but it could also activate these CD8 T lymphocytes. These are the Marines. These are the guys that go and just destroy the cells. Okay. So that's the first part of what I'm saying. Now, in order to understand the second part, you have to understand that I have been focused on ACE2 autoimmunity. And my concern, part of the concern, is whether or not we see a reactivation of that when somebody gets infected again after their immune system has been primed from whatever source. So, in that sense, I then go back to the science. And what I'm looking at here, this is just a paper from 2021 talking about ACE2 and the angiotensin 1 to 7 and this renin angiotensin system. And it's just looking at the way how it works. But the thing that I was very, very interested in, and so I'd searched this in terms of this paper. If I can't find it here, yeah, there we go. So immunohistochemical analysis showed abundant ACE2 positive cells in diseased vessels, particularly in the neointima and media and in newly formed angiogenic vessels and vasovasorum. Okay, this is the bit here that really, really is important. And it's telling us that ACE2 is in the vasovasorum of these big blood vessels. Okay, now, in order to understand the significance of that, so I'm tying two things together here now. The fact that the vasovasorum, I'm trying to think if I have an image that will show you that. I had it before. I'll have to see if I can find it while I'm talking to you. But the vasovasorum represents the blood vessels that are supplying the blood vessels. They are like the blood vessels inside the blood vessels, and their role is to keep nutrition to the lining of the blood vessels. Okay. And I think that this is such an important point that I'm going to show you this one here. I just have to find the image because you need to see it in order to understand what it is that I mean when I talk about the vasovasorum. Because this is potentially the mechanism that leads to what the embalmers are seeing with the large clots. This is why I said that I'm tying a number of things together. And this CD8 targeting is very, very critical in the picture. So here is the example of a large artery with the vasovasorum. Once the image comes up here, you'll be able to see what I'm talking about. And this vasovasorum, based on what I was saying, can then get targeted. So this is a large muscular artery. It's not quite the aorta, but one there. So this is the smooth lining of the blood vessel. Now, this has to be smooth because if this is anyway even a little bit rough, it will automatically start to clot. And you can see the muscle layer here around this artery. But on the outside here, this represents where the vasovasorum are. So these blood vessels here, this is the artery, this is the vein, they carry the blood supply. This is it here. Red is artery, blue is vein. So this is supplying the outside and giving nutrition all the way to the inside of this very big artery. So even though it has blood flowing through it, it's not being supplied with oxygen from this blood. It's primarily from the vasovasorum around it. So anything that damages the vasovasorum is going to then damage the lining inside the large blood vessel and therefore lead to clots. So what I'm saying is that ACE2 is predominant, is highly concentrated in these vasovasorum. So suddenly, if you have the immune system then targeting these cells, you'll get inflammation. It will then reduce the oxygen supply, and then you'll have damage to the lining of this artery, and then this will lead to clots. And this is the essence of how the combination of two things seem to make sense. One is the autoimmune targeting that would occur. And just so that you understand what I'm talking about with regards to this targeting that occurs, remember, it's not just antibodies that will target the vas vasorum, but these T cells. And what they'll do is that they will kill any cell that has ACE2 on it. And that will then mean it will cause blockages in the blood vessels there, which will reduce oxygen supply, which will then cause inflammation and damage to the big artery, which will then lead to clots. So it's this sequence that I think is occurring. And if you hadn't seen what has been happening with regards to embalmers clots. This is another thing that remarkably has just been ignored. And if anyone has access to JFK, please tell him that this is the kind of thing that needs to be urgently investigated, because we thought it was only occurring with embalmers. But I had heard from a whistleblower, and he had shown me some of these clots. So this is the kind of thing that you would be seeing here. This is a clot from a large vein, which will also have a vas vasorum, and this was removed. So huge clots, and they're white as opposed to red, a normal red clots, and they're very fibrous, hard to break down. So this is what is occurring, and I think that there's a combination of things. Now, it's important to know that the damage to the endothelium causes clotting, but it doesn't necessarily cause the white fibrous clots. That, I think, is also part of that autoimmune mechanism, where in a presentation where I did looking at it, I said that what had happened is that the immune system literally went into overdrive, potentially after an infection and immune priming, which then led to these kinds of clots. And the reason embalmers are seeing them is because, in effect, if it occurs and it's serious, they either end up in hospital and have a big clot removed, or they would die, which is why an embalmer would see it, and it wouldn't necessarily be picked up in a normal scan. But based on everything that I've seen, patients are usually quite sick around the time that they're making these clots. So we have a lot to be able to try and learn to make sense of it. Now, that bit, as I said, tied in to exactly the histology that we know. So this is why I'm saying I'm taking you through this journey. And you can see here now, so this is a paper that focuses exactly on what I said: thrombosis of the vas vasorum in the large and medium-sized pulmonary artery and vein leads to thromboembolism in COVID-19. These are clots. So this is a perfect example of what I consider to be a COVID storm. These people then got infected and then ended up with this kind of inflammatory process in the vas vasorum, which then led to these clots. And this is what one of the clots looks like in one of the blood vessels. Then they can't get the blood supply. It causes damage to the lining of the big artery, which then makes another clot. And so this whole sequence is definitely occurring. So this is not theoretical. The question is it just occurring in a few people? Because in this case, they had 3 patients who had COVID and then ended up with this. How many other people could have had even milder disease and ended up with clots that they didn't know were necessarily relevant? This is the kind of thing that we definitely urgently need to be able to understand to make sense of what is happening around us. I take you back to the general principles. The reason why I'm talking about this is because there is a problem. Excess mortality, in case you've just joined, this is the reason I started talking about it. This period here, with up to 52% mortality in January of 2021, this is now September of 2021. This is the January of 2022. Whatever intervention they did here seemed to have had limited impact in terms of what happened with the Delta wave and the Omicron wave. But beyond here, this is Omicron now. What is causing this excess deaths up to, and the highest point here, this was in 2022, 23% excess mortality in January of 2023 in the United States. This is completely unacceptable. And as I said, this is part of the reason why, even though people may argue about the qualifications with regards to JFK, I all I can say is that any major organization who is not looking at this and not trying to address it and not trying to understand it, not insisting that we need autopsies and we need to try and see the patterns and coming up with ideas as to what could be the mechanisms. I think that if that's not being done, you definitely need a change, because where we are now, we need the people to be thinking. We need them to be looking at every single option. No stone must be left unturned. Now, I know many people will have specific ideas about why this is occurring. And anyone who knows me knows that I always talk about the elephant in the room. There's an elephant there. Everybody's baffled about it. But nobody quite knows what's going on, and nobody's investigating what exactly is happening with that elephant. That's my general rule. We need now leadership, health leadership. This is globally, that will not be afraid of looking at the elephants, looking at everything, making sure that every angle is explored. This is serious stuff. You can't be running a 10% excess mortality for two years and not be concerned, because they're based on my prediction with the fact that COVID continues to circulate. I don't see this dropping. I see this gradually increasing each year. So it's, came five, let's say 7 to 10% now. Next year, it could be, 9 to 12%. The year after that, it could be 11 to 15%. And it just keeps on rising if nothing is done. And that's death, not including the fact that people are getting sick. So something needs to be done. And the part of that, as I have said before, if you are interested in what I am doing in terms of trying to understand patterns and trying to help people to overcome it, make sure you get this health monitor. It's for free. You have to sign up for a newsletter, but we'll be able to share this with you. And then for people, it gives you a chance to look in detail at what's happening with you. And we've built it out to look especially at gut-related symptoms, because I think that this is the red flag for many people around COVID. But it's looking at weight, breathing, exercise, fatigue, all the things that could be relevant to people who are unwell and who want to stay well. That's the other part of the puzzle. You have to remember that one thing about COVID is that even though it infects the respiratory tract, one of the first targets once it gets into the bloodstream is that it then targets the GI tract. And that's why so many people are struggling with gut symptoms. Don't ignore them. It likely is putting risk in terms of subclinical inflammation that should be addressed. Don't ignore it. That's my view. But we have huge challenges ahead of us, because the science needs to be objectively analyzed. And we hopefully are moving into a phase where we can get more objective analysis as to exactly what has happened. And critically, if we understand the drivers for excess deaths, we can hopefully try and find ways that it can be mitigated. Have a great evening.
Some studies give people vitamin D3 and it gives them too much calcium in their blood, increasing the risk of hardening of the arteries like in atherosclerotic heart disease. Some studies give calcium and it can increase bone density, while someone else finds that it can increase the risk of heart and or artery problems. How can that be? How can D3 cause too much calcium in the blood as an essential nutrient? And studies show that a higher calcium intake can lead to both arteries worsening and bones improving in different studies at the same time. If you take vitamin D3, you need to pay attention to this video because it can seriously help you make sure that your heart and arteries aren't at risk. I'm going to go into quite a bit of detail that I don't think any doctor in the world has ever put out, let alone on YouTube, that I know of anyway. And it's not going to be quick, but if someone you know takes D3 or yourself, sending them this video could help save their heart. And I know that's a bold claim, but if you watch all of it, I think you'll agree with me by the end. See, a short while ago, I was speaking at the Royal College of Physicians in London. There was someone there called Trevor Stain, who started a skincare company called S. He stood up at the front and he said, D3 supplementation is extremely dangerous because it causes hypercalcemia. Honestly, I was so keen to go up to the front and disagree, but luckily, I withheld myself out of respect and I stayed where I was. But that statement is extremely misleading and is a complete abomination of statistical inferencing. You see, he represents what practically every doctor on the planet says. However, regular viewers of this channel know my blood tests are public, and specifically they show that I have a dangerously high level of D3. Now, why have I been told it's dangerously high? Because it apparently causes hypercalcemia. But if that's the case, how is my calcium level perfectly normal? If the medical establishment is correct, how am I living proof that D3 doesn't cause hypercalcemia? I'll tell you how. Because the daily recommended intakes, the medical guidelines, and commonly accepted nutritional advice is a complete load of rubbish. And if you think I'm some sort of conspiracy theorist, explain to me how I have toxic D3 levels and no hypercalcemia then. And I'm not the only one. I'll get on screen here a scientific paper of 2 case reports where 2 people were taking an exceptionally high dose of D3 every day. Now, one had hypervitaminosis with hypercalcemia, and the other was absolutely fine. How is it possible that only one had a problem if D3 causes hypercalcemia? What I'm going to teach you now should have been taught in high school and at the very least in medical school. Obviously they weren't. The video is for my friend Nikki that was told by quite a world-famous biohacker in the world of health optimization to use a K2 supplement from Thorne, which, as you'll see by the end of this video, I think is absolutely terrible. Now, this biohacker is a complete moron and has no idea what he's talking about, most of the time at least. Calcium in the bones is perfectly normal. Calcium in the arteries is problematic. In other words, hypercalcemia. D3 causes activity in the realms of calcium regulation in the body. The exact mechanism, when understood, brings about safety to each and every one of you that supplements with it at home. Now, ideally, you'd be getting D3 naturally, but I fully understand that that's not always possible for some of you. I certainly have trouble at times because I travel around the world a lot and I never stop working, basically. So let's take a closer look at that mechanism. D3 and K2 play a crucial role in calcium metabolism. They work together to ensure that calcium is efficiently absorbed and directed to the appropriate areas in the body, such as bones and teeth, and away from soft tissues like arteries, where it can cause harm. One of the first things that D3, which is cholecalciferol, does is enhance calcium absorption. It's converted into its active form, calcitriol, which is 1,25-dihydroxyvitamin D3, in the liver and kidneys. Now, calcitriol enhances the absorption of calcium from the gut by increasing the expression of calcium-binding proteins in the intestine. In other words, D3 causes us to make proteins that are used in binding calcium around the body. It can help us to regulate this mineral, this calcium. Calcitriol helps maintain calcium levels in the blood by promoting calcium reabsorption in the kidneys and potentially mobilizing or unlocking calcium from bones when necessary. Now, why would calcium need to be removed from bones? Surely that's a bad thing. Well, in certain circumstances, like, say, a sudden change in diet, temporarily sacrificing some calcium from the bones for a short period of time and then putting it back later can help tolerate the sudden change of diet. Hopefully, you will never need to liberate calcium from the bones, but we have that ability if needed. As well as inducing the production of calcium-binding proteins, D3 also influences the expression of other proteins that depend on K2. So you've got one set of proteins that get made to meet up with calcium for absorption, and you've got another set that need to meet up with K2 in order to sort that absorbed calcium, because we've got D3 present overarching the entire regulation. Now, the proteins which D3 makes that need to meet up with K2 are really important to know, and probably very few, if any, of your doctors will know anything about them. Osteocalcin and matrix GLA protein, MGP. Both of them need K2 to function properly. I'll explain what they are now. It's going to be quite detailed, and you may need to watch it several times. But it's worth it if it stops you or someone you know getting blocked arteries. I'm going to give you a brief intro to each of these two enzymes, and then later on I'll go into them in detail so that you can argue against anyone that tries to tell you they're not important, or that you don't need it alongside D3, or even to see whether your doctor knows what they're talking about so you can walk away if needed. So the first one is called osteocalcin. It's synthesized by osteoblasts, which are cells responsible for forming bone matrix or bone scaffolding called osteoid. D3 binds something called VDR, which is vitamin D receptor, and this causes the expression of the gene that codes for osteocalcin. Osteocalcin contains 3 GLA residues, each capable of binding a calcium ion. Now, these residues are located in the N-terminal region of the protein, the left of the protein, if you like, forming a really high affinity binding site for calcium, like a magnet. The GLA residues coordinate with calcium ions through electrostatic interactions, because calcium ions are positive. And the carboxyl groups on the GLA residues, once they've been carboxylated, chelate the calcium ions. And that creates a stable complex that's essential for the subsequent steps of bone mineralization. The second one is matrix GLA protein. It's a small protein made of glutamic acid residues. Now, once it gets carboxylated, again, I'll go through what that is in a second, it turns into gamma-carboxyglutamic acid residues. And now it can then bind calcium very well. Now, when these two link up with K2, there's a process called carboxylation, as I just mentioned. K2 is a cofactor for an enzyme called gamma-glutamyl carboxylase. It's this enzyme, when it has its friend K2 around, that carboxylates the 2 previous enzymes I've just mentioned. Carboxylation is a process by which a type of acid called a carboxylic acid is produced by reacting something with carbon dioxide. The reverse is called decarboxylation, where you remove a carbonyl group from a compound and release a carbon dioxide. It's this carboxylation that allows osteocalcin and matrix GLA protein to effectively bind calcium to themselves. This is because carboxylation confers a very high affinity for Ca2+ ions, calcium ions. Uncarboxylated compounds lack this capability, and so they're less effective in bone mineralization. Everything in biology is chemistry and physics. So the way you know someone knows what they're talking about is if they can go through it in this scale of detail, in the chemical interaction size scale. So now we've seen how these enzymes get activated by K2. It's important to understand the different types of K2 that can do this calcium regulation, and then I'll explain what osteocalcin and MGP actually do chemically in detail, because that's important to know. So there are multiple forms of K2 that exist. They're known as menaquinones, and they come in quite a few different sizes of their atomic structure. To make it easy, they're actually given names based on the size, and we get them called things like MK4, MK5, blah, blah, blah. So MK4 is the form found in specific tissues like the brain, pancreas, and arteries. It's one of the smaller ones, and a smaller amount of quinone is, the shorter its half-life in the body, its lifespan in the body. So MK4 has a short half-life, and it can regulate gene expression involved in bone metabolism, as you now know. MK7 is another important one. As you can tell from 7 being bigger than 4, it's a longer chain as a molecule because it has a longer half-life too. Well, it has a longer half-life because it's bigger. Because of this, it's effective in the longer-term regulation of calcium deposition in bones and preventing calcification of arteries. It works more systemically around the whole body, unlike MK4, which is more organ-specific, as I've said. So I guess now that we understand that D3 induces the production of osteocalcin and matrix GLA protein, and these two then depend on K2 to function properly, what happens when all of these boxes are ticked? What's actually happening inside your tissues when you have the right combination of vitamins or nutrients and minerals? Well, osteocalcin binds calcium and integrates it into the bone matrix, which promotes the mineralization and strength of that bone. Hydroxyapatite is the crystalline form of calcium phosphate that constitutes the inorganic component of bone. Osteocalcin facilitates the nucleation, which is the formation of a crystalline material from a solution, of hydroxyapatite crystals by binding calcium ions and concentrating them in specific regions of the osteoid or the bone matrix. This localized accumulation of calcium creates a kind of favorable environment for the formation of hydroxyapatite, which we also have in our teeth, hence why K2 is really important for dental health too. Now, once nucleation occurs, osteocalcin binds to these growing hydroxyapatite crystals. See, the protein structure allows it to stabilize this crystal lattice and promote the orderly deposition of additional calcium and phosphate ions. So this process helps to increase the size and density of these hydroxyapatite crystals in the bone. And that's what enhances the mechanical strength of that bone. I know that's complicated maybe for a lot of you, even actually to the consultants that I've taught that to for the first time. But I advise you to watch it back several times if you need to in order to understand it. Osteocalcin works in concert with other bone matrix proteins like osteopontin, bone sialoprotein, etc., etc. And they also contribute to the mineralization and the regulation of calcium deposition. But if I go into those as well, this already long video is going to be way too long for the average person to not get a headache from. So I can talk about those in another video if you guys want. Now, matrix GLA protein, on the other hand, prevents calcium from being deposited in the arteries in order to prevent vascular calcification and improve artery health. It keeps it flexible instead of rigid. Now, it does this because when it binds calcium, it prevents it from being deposited in the arteries. The calcium's trapped in a way, right? When you hold a child's hand, they can't then go and run into the road because you're holding them back. MGP has a relatively complicated life, like osteocalcin, which I'm going to teach you too. It directly interacts with hydroxyapatite, which is, again, the crystalline structure of calcium phosphate, and it inhibits its nucleation and growth, but within the vascular system now. So the protein binds the surface of young hydroxyapatite crystals and prevents further growth and propagation. And this action is what impedes the calcification process in the initial or early stages. Now, MGP does this by inhibiting the activity of something called BMP2, which is a signaling molecule that promotes osteogenic differentiation and calcification of vascular smooth muscle cells, so cells that are making up our arteries. So by binding to BMP2, MGP prevents it from triggering pathways that lead to the transformation of these smooth muscle cells into osteoblast-like cells, which are responsible for depositing calcium inside arterial walls. Now, MGP plays a crucial role in maintaining the state of these smooth muscle cells, preventing their transdifferentiation into other types of cells that contribute to the calcification process. Through its inhibitory effects on BMP2 and other, calcification promoting factors, MGP helps keep vascular smooth muscle cells in their contracted state, which is essential for normal vascular function. It also binds to extracellular matrix components, bits outside the cell, in the vascular wall, such as elastin and collagen, which are crucial sites for calcium binding and deposition. So binding to these ECM proteins, it also prevents calcium from anchoring to the matrix and forming calcified deposits where they shouldn't be, thereby protecting the structural integrity of the blood vessel. So adequate levels of active carboxylated MGP, matrix GLA protein, are crucial for preventing arterial calcification and maintaining cardio health. Low levels of carboxylated MGP are associated with cardiovascular disease. So this is why some studies find calcium supplementation gives artery calcification and others find bone density increases. It's because the researchers are so poorly educated that they don't know about K2 activity and osteocalcin and matrix GLA protein. This is how I have massively high D3 levels, but my calcium is absolutely fine. Because I understand this pathway and understand how to safely create supplement regimes if needed. If is the key word there, by the way. The ideal diet shouldn't need supplements on the whole. So based on that, where do you find K2? Which supplements should I use if I need it? Well, menaquinones are found mainly in animal tissues like organ meats, chicken, beef, grass-fed, pork, cheese, eggs, duck, I think even geese. So if you think humans are designed to live plant-based, then you need to grow up, frankly. The fact that this thing is essential and you get it from animals should tell you something. And as you can probably guess, as a carnivore, I'll be absolutely fine. But what if you do need a supplement? Well, first off, that's a sign that clearly your diet isn't sustaining you and you need to change. But if supplements are needed for whatever reason, then here's some tips. MK4 and 7 are the forms that you'll find in supplements. The others like MK5, 6, 8, 9, 10, 11, 12, etc., you're not really going to find those. But here's where people get scammed. MK7 exists in two forms, cis and trans. I won't get into isomerism chemistry with you because it will confuse the hell out of everyone, but just understand that there's two forms, cis and trans. The trans form is the type that's found in nature and in what we eat. This is why I don't need to worry. I'm always getting the right form on a carnivore diet, and there's no plant food preventing the absorption. Because yes, plant food does prevent you absorbing what's in the meat. Now, if a supplement says MK7 on the back, then some will be trans and some will be cis. If they don't say, then either they're too dumb to realize one is more important than the other, or they've got a mixture and they don't want to admit it. That's why the best K2 supplement on the market, in my view, is Super K by Life Extension. Before anyone thinks it, I have no affiliation with the company at all, and I have no affiliate link either. If you look on the back, it clearly states that all the MK7 is trans and not cis. How much do you take? Well, I suggest to my patients that for every 10,000 units of D3, they take 1 Super K a day. So a patient of mine that is on 5,000 a day of D3, they take 1 Super K as well. I can't give a recommendation to you all because when I set the levels for my patients, I do it as part of something called a personal health management service where we get a lot of tests like bloods and body scans done, which help me see what they need. They'll come to me with things like obesity or diabetes or polycystic ovary syndrome or epilepsy, or something. And they say, look, I want you to make me better. I want you to make me healthy. It's part of a service I do called personal health / disease / longevity management. And as part of the baseline measurements, I'll see the D3 level in the blood tests, as well as a load of other things. So I can then give a recommendation. Now, if you ask me in the comments how much D3 and K2 is right for you, honestly, I'm sorry, but it's literally impossible to say without seeing you and examining you. There is data available from studies that look at different doses of K2 and its history and things like that. But this video can't go on for hours and hours, unfortunately. But hopefully this has been educational. And hopefully it has told you not to listen to the people that give you supplement advice that don't know these things like cis and trans and the different forms of menaquinones. And hopefully I'll see you in the next video. See you soon.